All right, so trust you all had a decent weekend. What's going on with me right now is that I'm starting to teach an online class. And so I am going to be around here on Tuesday and Thursday, just for those who might be interested. If you need some extra help or whatever, I'm going to be around a little bit more. But certainly that's up to you. What we're looking at here today, being the 4th of June, is that we have homework set number 5. And I had a few people who contacted me and said they were having trouble entering the information into the computer. And so I said, okay, well, let's just make it due tomorrow. So it's due tomorrow. And at the end of this time period, we're going to have some extra time, hopefully, and we'll go over to the computer lab, not the computer lab, but the other room that we were in last time. And if you don't have everything set up right or completed, then you can finish it then. And we'll just make sure that everything's working as far as the software and everything so that we don't have an issue with that. Certainly it's the case that, you know, having a computer at home or a laptop or something like that, it might be a software thing, and I might not be able to fix that. And so then it might be something where we can get you in contact with customer service and get that squared away. But certainly the computers here at school should be fine, and so then you can at least get the assignment done, right? Even if there's some issues as far as the software goes. And certainly it's the case. These deadlines that I have for you are so that we continue to keep on the move properly. But if something happens, let me know. I'll change it. Doesn't matter. If you're not able to get something done, or if something gets in the way, or whatever happens, just let me know and I'll fix it. Okay, that's the deal. I'm not trying to make these due at a particular time in order to force you to do something other than learn. All right. So if you have trouble learning it, let me know. We'll change the due date. That's not a problem. Okay. Anytime you get to a point where you say, I don't understand this and I can't get it and it's due tomorrow, I'll fix that. But then that still means you still have to learn it. Okay? So the due dates are there so that we can continue to make progress, but they are flexible if something comes up. And if it's a computer problem, certainly, I'll just change the due date. That's not an issue. But you will have to get it resolved so that you can get it done. All right, that's the deal. Speaking of getting things resolved, so then we're not going to worry about the homework right away, but we will talk about exam number 1. And so what I want to do here is just talk about a couple of things regarding exam number 1. I'm going to give you the breakdown here as far as the grades on exam number 1. That we had 8 A's, 11 B's, 5 C's, and 4 below. So that's pretty good. All right. If we look at the median, that would be a B. All right. So that's decent. That's what we want. All right. However, there were some people that had trouble. And how that turns out, okay, when we say, what does that mean? Well, if you had, let's say, well, anytime you get below a 70% on a test, it's possible for you to do a retake. And so then you can do the retake, and then the maximum score you can do on the retake is 70%. However, if you're way below 70%, then you would need to maybe do a lot of work in order to be able to get up to that level. 70% is the level where you're going to be able to pass the course and get the credit that you need in order to move on to the next thing. Now, it might be that there was just something wrong that particular day. And it was just, you know, you knew everything, you knew how to do everything, but you just couldn't do it that particular day. Then that's an easy fix. You just come in, you just take it in the room next to my office, and then you're fine. However, if you don't know how to do the things, then that can be a problem, because it might take you like 8 or 10 hours a day for 3 or 4 days in order to learn everything. And at the same time, you have to be able to keep up with the rest of the class. And so it might not work, okay? It might be that this is not the time for you to continue to work on this. I don't know the answer to that question. Certainly, if you benefit from continuing to work on stuff, that's good. But I think you need to be realistic. If your score is significantly lower than 70, then you might think about, well, what's the next thing that I really need to do? It might be that you need to spend a ton of time trying to do something, but it might be that you need to take the class later or something. I don't know. But specifically, I just want you to understand that this is not a thing where I think that you're a horrible person if you get a bad grade or anything like that. This just might not be the time for you to take the class or something. Or there might be something else going on, and I don't know. But it needs to be fixed, whatever it is. And for those of you that did get a C right now, I just want you to be aware of the fact that the next test is going to be more difficult, and then the next one's going to be more difficult than that. So you kind of need to turn the crank a little bit more in order to maintain that C level. And those of you that get A's and B's, well, that's great, okay? Except for the fact that the next test is more difficult. So if you want to continue to do well, you're probably going to have to work a little bit more than you are right now. But we'll see. Some people, it just comes naturally to them and they're fine. Other people struggle. Other people are in between. And again, A's and B's are good, and by definition. And so then that's what we want. So now what I'm going to do is I'm going to hand these back to you, and then we're going to go through the specific questions to be able to see if there's something that needs to be fixed. As it turns out, these definitions that are at the beginning of this course, you're not going to have to worry about them again. Okay, so it's not like, oh, this is going to come back later, I better learn it. Not really necessarily, okay? But there's things about the graphs and about some of the other calculations that we are going to use over and over and over again. So I'll hand these back, and then we'll go from there. And like I said, we do have a little bit extra time today to make sure everything. Yeah, I think it's
And you say, yeah, the other day, frustrated. My handwriting used to be really, really horrible in elementary school. Yeah, so I left handed. And so then I started reading cursive. Yeah, then I felt And I just see my dad, I guess mine is not necessarily like textbook courses, but his is like way more of like a mix of like use the letter and
I don't look over the process.
Yeah.
All I get is there.
Just to feel a little different.
So if you eventually end up with something,
Is there anywhere on the website that you can do like practice problems?
yeah, I'll show you where that is.
Okay, Jeff.
Number. Yeah.
Oh, the definition.
Now, as far as I understand it, there's a certain amount of, I don't want to say this, just experience. We talked about this. Experience helps you to know what to do in a situation. And I have some experience on giving tests. You have some experience on taking tests. But that doesn't always work, okay, for whatever reason. Just doesn't always click the way it's supposed to. And so, as it turns out, I made an error when I was doing this about systematic sampling. So I remember pretty clearly, you asked me, do we need to know about the different kinds of sampling? And I said, really, the only thing you need to know about is random sampling. So then when I put a question about systematic sampling on there, and nobody gets it, then I'm like, oh, yeah, well, I'll throw that one out. So I did. So I threw that one out. Some of you, however, knew what systematic sampling was and got 1 extra point. Because systematic sampling is when you take every certain number of things, like every 5th one, and you pick that one, and you go through the line like that. That's systematic sampling. Or the upper right corner of the bookshelf was the one I used. Okay, whatever that thing is. All right? However, for those of you that may not know this, if a question asks, what's the definition, you cannot use the word in order to define itself. So if I said, what is a frumptious person? And you said, oh, it's a person who's frumptious. Well, that doesn't really tell me what that means, right? Okay. So when I say, what is random sampling? If you say sampling that is random, that doesn't tell me what it is, okay? And I said that random sampling means that every sample has an equal chance of being chosen. That's the definition of random sampling. Okay. Now, regarding the internet question, explain why internet, oh, by the way, there are 2 different forms of this test. There's a Form A and a Form B, and they're in different order as far as the questions go, okay? But the internet question, why are internet surveys inaccurate? If you say something about question order or something like that, well, that's not really specific to internet surveys, okay? So there are 2 things I was looking for in internet surveys. The first one would be that it's only people who are interested who will click on the survey. And so then that affects the results. The second thing, which we may not have talked about very much, is access, or finding people. People who go to a website are not randomly selected, okay? So then neither one of those things for the internet would be random selection. Now, if you say they could lie, well, they could always lie, all right? It doesn't matter. So I was looking for those 2 specific things as far as internet surveys go. Then the question of bias. When I ask the question, how does age distribution create bias in the results? What does that mean, create bias? Bias means something is going to affect the results of the research. Okay, bias does not mean that they hate young people or love old people. Okay, it's the matter of how it changes the results of the research. That's what bias is. Something that changes the results. Okay, now, what that means is that if the community has a bunch of young people versus a lot of old people, then your research would be different in those two different communities. So the distribution of ages would affect the results, so you wouldn't be able to say it's always this way or always that way. Okay, that's what that means. Now, similar problem with the question about real estate. Okay, explain why the median is used and not the mean when describing real estate values. Some people said because of the resistance of the median. But I specifically asked the question when describing real estate values. And so it would have been better if you had said, because real estate values have extreme values that would change the mean, and the median is not as effective. Other people said, well, real estate has a lot of extreme values, but that doesn't explain why you would use the median. Okay, if it has a lot of extreme values, you say, and then that changes the mean, but not the median. So you had to have both of those ideas in there, all right, in order to get full credit for that question. Once again, truth in advertising here, you're not going to see this again. We're not going to talk about this kind of stuff very much anymore, all right? We will talk about skew distributions and a little bit of that kind of stuff once in a while, but this is not going to be a big deal in the future. All right, so any questions about part A? Anything that's not clear about part A? Okay, so part B, create the appropriate graph from the data which is given. Some of you had, if you had form A, then you had a bar graph for the first graph. If you have form B, it's a histogram for the first graph. And in both situations, if you're doing a bar graph or a histogram, you cannot have something that looks like this. This is not correct. You're doing either a bar graph or a histogram. You cannot have things that are spaced out by 10 and then suddenly go to 0.
What is the difference between the two?
Okay, a bar graph is when you have categories, like people from Iowa, Minnesota, and Wisconsin. That would be a bar graph. And the bars, let's make this 60 and this 30. The bars are not connected. That's a bar graph.
Can they be?
No, not for a bar graph. If you're doing a histogram, then you're going to have data groups on the bottom, like 5 to 9, 10 to 14, etc. And you will have connected bars, and you will have frequency right here. And data groups. There. This is a histogram. That's a bar graph.
You said Form A was a bar graph.
Form A is a bar graph. Form B is a histogram for number 7. Okay?
So for that bar graph, you would start at 0 and go 10, 20, 30.
Or you can go 40, 80. Doesn't matter what the scale is, but it has to be evenly spaced and it has to have 0 on the bottom if it's a bar graph. Because what you're comparing is the size of the rectangle. You're not just comparing how high they are. You're comparing the actual size of the rectangle. So that's why you have to have an even space on that vertical scale. Okay? So for number 8, number 8 has time. It has the year, 2004, 2006, 2008, etc. Whenever you have change over time, that makes it a line graph. That's a line graph. Some people were confused, and I understand how it might be confusing, but still, if you understand the idea, this has to be a line graph. Some people saw the word percent and assumed that it had to be a circle graph. Well, actually, a circle graph is not one of your choices. So if you look at the instructions, you say it has to be one of those three. Well, if it's change over time, it has to be a line graph. Okay, and it is okay in a line graph to start at 5 and go up to 6. Line graph is okay to do that. Okay. Any other questions about part B? Okay, part C, most people did fine. Part D had some issues, but there weren't things that were, how shall I say this, hugely wrong. They were just the standard kinds of things. People have made mistakes at various times. And then once again, number 17, I made a mistake when I said comment on the usefulness of the empirical rule for this data set. Well, that's too general of a question. Is it useful or is it not? Well, maybe it is, maybe it isn't. But the question I should have asked was, what relation to the shape of the graph for the usefulness of the empirical rule? Based on the shape of this graph, is the empirical rule useful? And then you would say, it's bell-shaped, so yes, it's okay to use it. Or you would say, it's skewed, so therefore it's not okay to use it. Now, as it turns out, some of these are a matter of opinion. So then I had to be a little bit careful about how I did this, especially the outliers. Well, that's a matter of opinion. And so then I could take multiple answers to be correct. But the concept of the outlier is not an empty space. The outlier is a data value which is separated from the main data set. So that data value is the outlier. The space is not the outlier. The data value is the outlier.
Why didn't you ask for if you wanted a specific, like values that the outlier was, why didn't you ask for that?
Yeah, well, when I say comment about outliers, it's using the data set. Okay? So it's not just a general comment about outliers in general, because this whole section, part B, is talking about that data set. That whole thing. 11 through 17 is all talking about the data set. All right.
I'm kind of confused on the outliers.
Okay. Which do you have, Form B or Form A? At the top of the page, what does it say?
Form B.
Exam 1,
Exam
Form
1, Form B.
Form B. Okay. So then, if we're looking at Form B here, and we're going with the if we take a look at that graph of that, okay, then that's going to be back here. Introductory stat, test items, stat test 1. Okay. So we're looking at this right here. And we say, what are outliers? Outliers are anything that's separated from the main data set. So if we say, where's the main data set? If we look at it as being kind of in here, then outliers would be things that are clearly separated from the main here. So then I would say probably these two, maybe these down here. Because the main data set is here, and then these have a gap to show that they're separated from. Okay? All right. Any other questions about part D at all?
Do you think if you want something like that next time, because then you want like what you want, so you know what you're looking for?
I will, yes. Now, in another sense of the term, what I would say is that, and this is going to be just in general, okay, that when I have a specific section of a test and I give you a data set, all those questions are going to have connections with that data set. So then you're going to see that again. All right. So that
specific values, even if it doesn't specifically ask for that.
if it doesn't say, you know, if I say things like describe the connection of this with that, I want your answer to be having to do with that data set for that section.
Not just a general answer.
Not just a general set, right? Not
So
just
you
a
want
general answer.
actual numbers connected to your general statement about that data.
Right. And that's generally going to be true. All right. All right. Any other question about part D? Okay. Part E, most people did not have trouble with. Part F as well was not a huge problem. Although there were some things going on there with regards to making percents and having the percents be accurately represented in the circle. We did a few of these in class, or a couple at least, and again, the concept is you take the percent of the total, and that's what the graph is about, the percents of the total. So if you make the graph, you need to have the percents as labeling the parts of it, and they should be relatively accurate. If it's 40% and 10%, that should be 40 plus 10. It should be about half the graph for the 40 and the 10. Okay, and those things, you know, again, it didn't have to be exact, but it had to look more or less like those percentages in relation to each other. All right, but definitely they need to be labeled with the percent. All right, any further questions about anything on here, any of these parts, any of these questions that you want to look at? Another thing that I just want you to know, you're not going to have to do the standard deviation by hand after this point, okay? You'll have plenty of other things you'll need to do, but you're not going to have to do the standard deviation by hand. If you have a homework assignment and it asks you to find the standard deviation, you can put in Microsoft Excel, or you can use a graphing calculator, whatever you want to do. You don't have to do it by hand. In fact, I recommend that if you get a homework assignment, which you will, and you need the standard deviation, which you will, that you put that into Microsoft Excel, just like we did it in the other room, and you just click on the thing and you get the standard deviation, and that's it, right? So you don't have to do the calculation of the standard deviation by hand ever again, because you've done it here and that's taken care of. All right. If you have any other question about anything on the test or anything about the grading or something like that, then I'm certainly willing to work with you on that. Natasha, I'll probably go with giving you a couple of extra points, all right? So if you bring that up to me at the break time, I can make that. All right, so that's that. Hopefully, that's number one. Now we need to consider the what's going on with the homework that was due for today. I want to kind of take a look at that here.
You don't want things back.
I do not. I do not. Okay. Where's my test 2 practice? Oh, there it is. Okay. Yeah. So let's try one of these. Let's say I've got a box. It has 7 light bulbs in it. 3 are 7 light bulbs total. 3 are bad. I'm going to take out 2.
Is this one like 8 or 9?
I don't know.
They were both rough.
Okay, well, I'll take a look at that in a minute, all right? But right now, I just want to finish writing down the problem. So I'm going to take out 2, and I want to know the probability that they are both good. All right, I'll give you 90 seconds, see if you can come up with this answer. All right, so now it's a group project. See if you can find out from somebody else how they did this problem, or how they started it at least, and see what they got.
So, and then it would be what? 4 times 3 there's 7, 6. Yes, for sure. So it's just different. That's way faster. I'm doing that was trying to get us to see it doesn't happen. Because it would be good.
All right, let's see what we got going on here. So, Kelly, can you tell me what you got for an answer?
I think I can work my way through it.
Oh, okay, well, let's do that then.
Okay. So, I thought I had my notes in front of me.
Oh. No.
Yes, I was busy talking.
Yeah, oh, busy talking. Well, all right. Busted. Allie Peterson. You got an answer?
Were you asking me?
Yeah.
Okay.
Lissa, sorry.
Yeah, yeah, so I didn't get that far.
Okay. So Alyssa, can you tell me, when you look at the box, how many good ones are there? 4. So what's your chance of getting a good one on the first pick? 4 out of 7, that's right. Okay, so the first one to be good is 4 out of 7. Okay. What happens after you take that good one out? Alyssa, can you tell me? Okay, and how many of them are good? 3. So what are your chances of getting a good one on the second? 3 out of 6. So in order for this to work, I want this to be good and I want that one to be good. So I'm going to multiply these 2 times each other. Now you can get a decimal number or you can get a fraction. Either way would be correct, but you would get an answer. Okay?
Can we divide it at the end and not do that part?
Yes, you can. There's another way to do this problem, but we just did it this way. We could also say there's 4 good ones for the first time, then there's 3 good ones for the next time, so there's 12 good ones. 12 ways to do that. And then we can say how many total ways are there? There's 7 and 6, which would be good. So then, yeah, it comes out to be the same. Either way.
So now I got this.
So then you take 12 divided by 42 and you get a decimal number. And we're going to round that off, or we can do it as a fraction. Same as 2/7. There are 7 total bulbs, right? There are 7 total. So when we have 7 the first time, we take 1 out, we have 6 the second time. So yeah, it's the number, the probability they're both good is going to be the number of outcomes divided by the total outcomes. How many total ways can we do this? Well, we had 7 bulbs the first time. We take 1 out, we have 6 bulbs the second time. So that's 40. And that's the number that goes on the bottom. Okay, question?
So I didn't mind the way that we did it in class last week, where you like made like all the possible choices and then put 1 times 4 and then you have 3 left. And I got 36 for all.
Okay, if you start with 7, okay, if you go 4 and 3, that's your good, that's 12. If you do 4 which are good and 3 which are bad, that's 12. That would be good, bad. If you do bad and then good, there's 3 bad and 4 good, which would be 12. And then if you have both bad, you have 3 bad and then 2 bad, which would be 6.
Oh, I just messed up one number.
Okay. So my illustration here is that when we did it in class, we did it so that you could see all the different possibilities. Okay. But in order to actually get this number, we don't have to make a list of all the different possibilities. If we can just keep track of how many bulbs we have and how many of them are good, and then what happens to them, then this is a bit shorter than going through this process. Okay? So if we're going to do it this way, less work, and we get there faster. And we get the same answer as if we added them all up and we made a list of all the different possible things that can happen. Either way is okay to do. Seems reasonable to do it this way. Faster, quicker, stronger, whatever. Right? Let's do another one. let's say I have 15 people in the office. There are 4 that have the flu. I choose 2 people. What is the probability that neither one has the flu?
Oh my God. I don't know how to like time it into the calculator. Stop. If I could open my eyes.
Okay. Right.
I don't know how to do that these days. Jenny.
I feel like this class needs to come with motivation. You are great.
I am all right. I just need
Part of the class.
calculator.
Self-help group.
All right, what I want you to do now is to make sure you check your answer with somebody else, okay? This is not a solo effort, I hope, but that you can actually ask somebody else what they think about your thing, right? See if you can get an answer here. All right. All right, Kylie, what do you got? How do you get it?
Well, I took 11 over 15, and then I times that by 10 over 14.
Okay. And I'm sorry, what did you get? 0.08, did you say?
0.524.
0.524.
Close.
Okay, so is it possible to use tree diagrams for this? Yes. Is it necessary? No, it's not. Just keep track of how this works. Not so bad, right? Okay. Now, I've got 240 kids in school. 180 are come on a bus. Let's use 60 coming the other way. Of the ones that are on the bus, 20% have the flu. I don't know why I always have the flu on these kids, but I do. Here, I've got 10% who have the flu. So, and then I'm going to ask the question, what is the general probability of having the flu? There are a couple of different ways to do this problem. I'll let you think about what you like to do.
Yeah, or you can do this one.
All right, so we got a couple different options here. She ran out. Danielle Cope, can you tell me what you got for that? Or?
For my answer, I got 17.5%.
17.5%. How'd you get it?
Well, I did 180 times 0.20, and then got 36 over that. Then I did 60 times 0.10, and I got 6, and then I added that up and got 42.
Okay.
Then I got 7 over 40, and then I changed it to decimal and got 0.175.
Yeah, that works. Okay. So when you say, all right, I want to know the general probability of having the flu, so then I can use number of children. Okay. The overall number of children is 240. So how many children actually have the flu? This would be one way to get that, make that happen. Okay. Now it's also true that I could have done this by using my multiplication principle. If I would say, what's the probability of being on the bus? That would be 180 out of 240, which is 3/4. And what's the probability of the other? That would be 1/4. So then I could take 3/4 or 0.75 times 0.20. 0.25 times 0.10. I can multiply the probabilities for each of those. Or I could use the numbers. And then I would add them together just like I did here. This would be if I times 0.2, that'd be 15. And this would be 5. So that would also work. Okay? So I can use the percentages of the children, find the total number of children divided by 240. I could also think about it using probabilities here. I could also get the same answer that way. It doesn't matter. To me, it's easier to use the number of children. But either way is fine. Jeanette.
Where are you getting the 0.20 and the 0.10? I get the 0.75 and 0.25, all the percentages.
Yep. Okay.
Those are issues I haven't on the homework. I don't understand the difference between the addition principle and multiplication principle, whether it's independent or dependent.
Okay. Do you know how to do this problem?
Now I do, I didn't.
Okay. All right. So that's what we'll work on after a half an hour. Okay, we're going to go through some new stuff, and then we're going to go over there, work for half an hour.
Like I did the homework, I got it all right now, but I still don't really understand it.
Okay, so what we're talking about here, when you say, when do we multiply? Okay, we multiply when we have a percent of a smaller percent, right? So I'm looking at this. These are the children on the bus. I'm taking the percent of them that have the flu. So what does this represent? These are children that are bus and flu. Okay, so that's why I multiply times 20%. It's the bus and the flu. The same thing is true over here. 3/4 of the children on the bus, 20% of them have the flu. So that's why we multiply. That's and. They're on the bus and they have the flu. That's why we multiply.
So and means multiply in every sense that we would see it in the question.
Okay, unfortunately, it's not a good idea to say always when you're doing statistics, okay? But when we say, if it looks like this, and it says the word and, yes, we multiply. Okay, but I didn't use the word and when I gave you the problem. I didn't say and. I said, here are the kids on the bus, here are the kids on the other. 20% of those kids have the flu. So the word of is another word that we use for multiply using percentages. Okay, but it's true. They are on the bus and they have the flu. And so then that makes it multiplication.
I think this is my biggest issue is when you look at a problem like that, I have no idea where to start.
Okay.
I see all these numbers and I'm intimidated by all these numbers.
Yeah, well, that's understandable. You haven't seen it before. That's why we're doing it half a dozen times. Okay.
I don't know if that was your question, but it's like, how do you figure out where you start? Like,
Right.
when you give the simpler questions like this first two, it's like, oh, yeah.
Okay, so what we're doing right now is that I'm showing you what those questions look like. Okay, what do those questions look like? They have a group of people that's divided into two categories. And then for each of those categories, they're also divided into categories. So you've got people on the bus, people not on the bus. People who have the flu, people who don't have the flu. Does that make sense?
Yes.
Okay, so when you see something like that, you're going to be multiplying those percentages. Okay, we're going to do another one. I sell TVs. When I sell TVs, 70% are 40-inch. I'm making these numbers up, I have no idea. And 30% are 50-inch. Okay. The 40-inch ones, 2% go bad. Of the 50-inch ones, 8% go bad. They're really bad. So what's my probability of having a bad television set? Overall? All right, check with your neighbor if you haven't already and see what you're getting for answers here.
Why not?
I don't like kind of percent.
Okay, that's my.
All right, Michaela, you got an answer? 0.038, or if we do it as percents, 3.8%. So how'd you get that, Kayla?
I changed 70% into a decimal, so 0.70, and multiplied that by 0.02.
Okay.
And then I multiplied 0.30 times 0.08. Then I over the, and then I added those together.
All right. So that's how that works. And again, this is the kind of thing which, if you haven't done this before, it's unfamiliar. You're not going to necessarily feel good or right about it. It's not going to make a lot of sense to you right away. But after time, it makes more sense. Now, that brings me to the next point that I wanted to talk about, and that was getting practice problems from your homework. Okay, so if we are there on the publisher site, and we make that happen here. Okay, so I'm opening up the site, introductory statistics. Up here at the top, it says resources. Okay, you click where it says resources, it has then practice problems. It has practice problems for every chapter and every section. So let's just say that we were going to probability and counting rules right here. We have section 1, section 2, section 3, section 4, section 5. Now, this is all of what the textbook covers, okay? So you wouldn't necessarily want to do everything that's in the textbook because we don't cover everything that's in the textbook, right? But if I wanted to say, all right, it's in section 3, then it's going to give you practice problems, 31 questions. There's no credit for this assignment. You can do it as much as you want, doesn't matter. And what they do is they go through each of these things and talk about it. Now, again, we don't do all these kinds of problems, so you wouldn't necessarily want to do this, right? Go through every problem that's in there. However, if you'll notice, this says 4.3 section, exercise 1. If you go to your textbook, you'll see this problem. Section 4.3, it's going to be exercise number 1. And then maybe the numbers will be different, okay? So this is doing exactly what's in the textbook, but maybe changing some of the numbers. If you go to your actual homework assignment, it also has that stuff going on. So if we go to homework set number 5, and I'm going to preview assignment here, okay? 4.1 section, exercise 10. Okay, so this is exactly like exercise 10 in the textbook, section 4.1. So if you look in the textbook, you can see how that problem is. And then if you go to the practice problems, you can practice a dozen of these if you want to. You can also do show example. And it'll show you an example. And you can do this however much you want. Okay? So yes, there are ways for you to practice this as much as you want to. Now, what I'm not completely sure about is what happens after you actually do a problem. Okay? The one thing I do know is it won't change your grade. All right? So there's no way that you can mess up your grade by doing practice problems. That's just not going to happen. Right? So those are a way for you to do that kind of a thing.
So we should look for the same section as our homework.
Same section and the same problem number even, okay? Because that'll be specifically the same kind of problem that you had on the homework, which is what I expect you to be able to do, okay? Now, we also had, okay, this is one kind, okay. First we had the bad light bulbs matching socks problem. Then we have this kind of problem, okay? The other kind of problem that we need to consider, and we're just going to take a couple of minutes, go through a couple, and we'll take a break, all right? And this would be if I have 5 people at the lunch counter. And if I know that the general probability, this has to be given to you, the general probability of having health insurance, say, is equal to 80%. I want to know what's the probability that they all have health insurance. So the general probability is something that you're given in the problem, and it says that overall 80% of these people have health insurance. But what about these specific 5 people at the lunch counter? I want to know what's the chance that all 5 of those people have health insurance. Okay. And while we're at it, the probability that none of them have health insurance. All right, make sure you check with your neighbor, see if they've got good answers here for these.
For which one? Having or not having? I got 4% for having. I don't know if I can.
All right, Jackie Miller, you got a number for me? The first one. Yeah.
327.
Okay. How'd you get that?
I just waited.
That's correct.
That's all you do?
That's what you do.
So, can I ask a question?
After we answer the last one.
Okay.
Okay. You have the last one there, Jay?
Oh, 0.00032.
0.00032.
Where does the fifth power come from?
Okay, because we're doing 5 people. If I did a tree diagram with this, I would have 80% and 20% for the first person, and then the second person would create branches. And every time I go down the branches, I would be multiplying. So I'm going to take 0.8 times itself, 5 times, that would be everybody saying, yes, I have health insurance.
So that wouldn't be the same as going like 5 times 0.80, 4 times 0.80, 3 times 0.80, is that not the same thing? Going through each person, 5, 4, 3, 2, 1 times 0.8?
No, because when we say all of them have health insurance, okay? The best way to answer the question is no, don't do it that way, all right? So we don't know how many of these people have the condition, okay? It's not like we're taking a large group and selecting a smaller group out of it. We're looking at everybody in the group, okay? And we don't know whether they have health insurance or not. Okay, if you're talking like the light bulbs, right? You had 10 bulbs and 3 are bad. You know how many you have and you know how many of them are bad. You have to be given that information. Then that's where you take like 3 out of 10 and then 2 out of 9, like that. Okay, that's this situation. You have a group and you know how many are in a certain condition. Over here, I have a group of people, but I'm given a general probability. That's a different kind of a problem. I'm given a general probability that they have health insurance or whatever else. And then I'm taking that probability and multiplying it like that. So the idea of the multiplying is correct. But here, we're multiplying based on what we know about their condition, either they're good or they're bad. Over here, we're basing it on the probability of them either having health insurance.
And that 0.2 is to the 5th power as well.
Yes, I'm sorry.
That 0.328, that's fine, that is fine.
Great question. We've got to round it off properly, don't we? So if I take 0.8 and I do it to the 5th power, it is 328. Jackie.
What, then you're wrong?
Is it round?
Oh,
okay,
sorry about it.
Jackie.
Sorry about it.
So there's that half point. I mean, you know, you got to get those half points right on the test. Okay. All right. We're going to take 10 minutes. We're going to come back at 4:23. Take about half an hour, and then we'll go over to the other room.
I'm assuming for I don't think it's different thing. Yeah, she did the walk that she left, but and then she came back and then we said, you know, and she, I know you are playing this list.
Okay, well, like I really wouldn't be able to probably. About yourself. This like this first response training. It's like this work. Sorry. Because it was that's pretty cool. You're not short at all. I was short. At 5'4". Actually, there's three. Like, there's I know. It's like,
There we go.
So last, like, everybody wants to, yes, I went.
oh no. Yeah, it was insane. I know, just you get like a ton of it's crazy. Yeah, so like for this summer training, like it's super expensive. Like,
You know how annoying that is?
to do it. What we're gonna do is go to the farm because they have like.
That is not a bad deal.
It's not, that's why I'm like, it looks good on your resume. It's really high, like, so it- and I feel like Christine, she said that she's not using it before stuff, but I think it's the first day of class, because I was training that.
Did she want to be like?
Or was for it. Used to like an outdoor.
Rain week 5.
Well, tell her that I'm gonna be very soon. She told me that, but she also didn't know that it was a good because I never emailed her. And I just did. So every time I email her, I see that he sent you a check-in. Check-in with you, that's what she said. I sent her a check-in. For touching base. I'm more worried about this.
You have access to your laptop. I know we're not working on questions right now, Rick, but can I still ask a question?
Sure.
Used last night.
So it's like,
Well, I was
oh, that we
too.
just did
Yeah,
5.
Yeah.
And then the question that we did number 3. Both of them asked the general probability of something.
But like I actually got it on.
3 asked the general probability of having flu.
No, I did too, and then later it was
Yeah.
gone. I was like, wait, did I
Yeah.
actually
Okay.
drop this class on
This
us?
one
Yeah.
asked the general
I was
probability
like,
of
what?
something.
And I was like, well, maybe I'll just give it till morning. But I'm like, I don't have time there, but I have
Yeah, he, in my class, was like.
Talking about
Yeah, to me,
general
like, go with
of
me, we'll figure it out.
Of the 240.
I mean, again, he's really brilliant though.
this.
Like,
is
so,
not
like, we did a
asking
bunch
you
of
to
tough
do
talks.
that.
His
Telling you.
maximum word response. Which is like nothing.
Okay,
I
it's
think
not
my
asking
class is
you.
the exact opposite of that. She's so strict. And she doesn't even live here.
Because it's not asking.
I don't remember what her name is, but she lives in like Arizona or something.
Oh, I took that last summer.
I love selective and not just.
Like it's gonna be cool and stuff, but like she's
Yeah, you
super.
do the challenge, you have to give them accountability.
To not, like, as a human.
Told her
like,
that
no,
it's-
oh, she split it up. That's what she
We're
did.
not
So,
finding
section
the
one,
general
the person that does the interview.
Finding the
Maybe it
probability.
wasn't that bad though. I remember
Is that his
like
name?
getting worried when I read this.
I'd rather do my own.
There was like, I think something about turning in work in a Blackboard Dropbox. I don't know what that I could probably look it up.
Because I remember, I'm pretty sure the projects were super easy to look at.
And like, what is a wiki? What's a wiki? I've never done a wiki.
Oh, like the.
I don't know. She said you have a wiki to this week, and I'm like, what the
Oh,
fuck's a
so
wiki?
normally have you read like an article or you watch a TED talk and then like write a few sentences or like a paragraph about it. They weren't that bad.
Asking.
I can't, yeah, so, but it was really good. I hate it, so because I'm not.
That's what I was just saying, it's kind of nice to
Everything.
in Arizona.
Or something.
I just remember reading through syllabus last.
I was like reading
So blackboard's down, but it's like, I always make sure to do my stuff ahead of time, because she's like, blackboard's down, like.
She's like, you know, all I have to submit it, I can't change anything. So she's like, make sure you have a reliable thing. I'm like, well, what if you're at school and
But
like
it
half
happens
an hour?
sometimes, so like, down for like half a day.
It'll be done for like.
No problem.
Yeah, and she's
How
like,
do you,
hey, you have a time to do that day.
like that problem we just did?
Yeah.
Yeah, I remember reading
Which
that.
like, I understand to an extent.
That right there?
But like.
Like, how can you dictate?
Sometimes, yeah, like I'm
what
trying to do it,
And like, I
like, yeah.
hate
There we go.
classes that require you to participate in
Alright.
one of these.
No problem.
No, I like that too.
Hers, she says it was 3 days a week, but my last online class had to go on and March was different. I'm like, to go on. Yeah, like, because if you have to do like discussion boards and you can't like post a discussion board and then do all your responses in the same day, you have to make it like active on the Blackboard.
Oh, for hers, yeah, I remember that, because you couldn't, it was like Thursday by 10, you had yours.
Yep.
But then you could respond until such, like, you had to wait till after Thursday, but then you had till Sunday or
See,
something.
it wasn't like, it's not like that, it's like the discussion board itself is due one day, and then the responses are due another day,
Yeah,
but you can't.
Today's
do
Monday,
that.
right? Yep.
yeah, that's how
And
hers
then she
was.
said I watched it, yeah, at least 3 times.
Did you take creative writing? I was gonna.
I'm not gonna be here on Wednesday. I just don't know if you want to know or not.
Sure, yeah, I do. All right, thanks.
like 3 assignments already due tomorrow. And like last night I was looking at it, and I was just like, before it started. Well, because I was like, if you do it before it starts, then it doesn't count as your grading year. And I was like, oh, I got more time. Last night, like,
That's what I'm like, how much you said, when I was on the
so I'm taking the online classes, I just because of the heat.
I don't know, I'm like, I'm gonna run for the accurate, sociology.
But later.
I got a little brutal.
All right.
I used to be able to go to the classes, but now I don't.
like to start so they have this like stuff. I was it's so much, but it's so cute. So I signed up for first round. It's literally in the middle of where we like CrossFit. Do you know where it's yeah, where we facing.
All right, so we're moving into the next section here. Pretty sure. Yep. So what we're looking at here is in chapter 5. So we are still talking about probability. We're going to move into a new area of things. So how many things? So let's consider the possibility. How many eggs have you eaten in the past 3 days?
0.
Okay, how many of you have had 0 eggs?
The last 3 days?
In the last 3 days. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay. Number of eggs. Hey, how many of you have had 1 egg in the past 3 days? 1. How many of you have had 2 eggs in the past 3 days? 3. How many of you had 3? 3. Okay. Anybody not raise your hand yet? Whoa. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. We're going to call you 4. No matter how many you've had. Say that 4. All right. So that's 10. And then 15, 25. That'll work out just fine. Okay. Now, what we're dealing with here is a frequency distribution, right? So we're talking about frequency over here, and we're talking about data values here. So this is something, if we wanted to, we could make a histogram out of this, because it has data values on the horizontal, frequency on the vertical, okay? We're not going to do that, though, because we're going to change these frequencies into probabilities. Okay. Now, how do we make something into a probability? What's the definition of probability? No, that's the description. That's the formula for probability. Okay, so the number in a specific set divided by the total. That's the formula for probability. Okay? So I have 12 in that specific set. How many total do I have? So what's my probability then?
Where'd you get 12? I'm sorry. Why did you get
12 people that had no A's.
Also, we do a probability for each one.
So what's that number come out to be? .48.
How did we get that? Can we like break it down?
12 divided by 25.
Okay. So we find the total, which is 25, and then we take 12 divided by 25, and it's 48. All right, what's next?
0.04.
Now, these are empirical or observed probabilities, right? You didn't roll any dice or anything. I asked you a question. You answered my question. I'm now making them into probabilities. Okay? So if I were to pick someone at random from the room, 48% chance that I would get a non-A eater. Okay? So those are the similar idea. Probability, percents. Relative frequency is another word we use, but we're using the word probability right now. Now, as it turns out, when we have something like this, where we have actual data values on the left-hand side, and then we create probabilities over here, it does allow us to find the average pretty easily, okay? So we have to talk, though, about what this is first. This is called a discrete probability distribution. A discrete probability distribution has specific numbers, like 0, 1, 2, 3, 4, like that. And then it has specific probabilities assigned to each number. So instead of being a frequency distribution, it's a probability distribution. And when we say discrete, we have specific numbers, 0, 1, 2, 3. Okay. Now I'm going to rewrite this with the letter X. Remember that X stands for data values. So I'm measuring how many eggs people eat. And then this next column is going to be P of X, the probability of that particular data value. So, now, I do apologize, I didn't mention this beforehand, but I'm going to make 2 more columns after that. So you're going to want 2 more columns after that. Now, as I mentioned to you, we can use this thing, this probability distribution, and we can find the average very easily. Well, easily, I won't say very easily. Notice, I just asked people how many eggs. I would have to, how many zeros do I have, how many ones, how many twos? To find the average number of eggs would seem to be kind of a pain. But we are going to have a formula that's going to give us what we want. The mean here. But you're not going to like how it looks. Just telling you right off. Looks like this. Okay, you're going to say, oh no, I thought we were done with sigma. No, we're not. Now the process here is not really mathematically hard. It's just that you have to think about what you're doing. Okay? So what you're going to do is you're going to take each data value, multiply it by its probability, and then get the total of those numbers. Okay, so that's what this next column is going to be. I'm going to take my data value here, and I'm going to multiply each one times its probability. Remember, the X inside the parentheses is not a multiplier, it's a label. So I'm going to take 0 multiplied by the probability of 0 plus 1 multiplied by the probability of 1, and so but it's not too hard here. 0 times this is just 0. 1 times that is just this. 2 times that. Now for some of you working with decimal numbers, you're going to be hitting a lot of buttons. For others of you, when you look at it, you say, oh, 3 times 0.12 is 0.36. That's not. When you get down here, you got to add them all up. You'll probably want to use your calculator for that. Abby, did you get a number?
1.6.
Oh, okay. Somebody else got 1.6.
Sorry, I thought you said Abby.
Oh, well, that's awful close. I could have said Alyssa or Alicia or Emily, but they're all pretty much the same. 1.6. Well, Abby got it. There we go. Abby, did you get that? Okay, that's right. Okay. So we got to keep our eyes on the prize here a little bit. What are we talking about? Eggs. How many eggs do people eat? On average, 1.6 every 3 days. Okay. Is that a reasonable number based on what we have? Yeah, it's kind of reasonable. There's a lot of people who don't eat any, but there certainly are people who do. And so to say 1.6, well, all right, more or less, kind of works. Okay. Now, are there any unusual values for my data set? What would be unusual? 1, why would we say that 1 is unusual? It's a less than 5% chance. So if I'm just picking people at random, would it be unusual for me to find somebody who just ate 1 egg? Yes. Okay. Now, this is kind of crazy because most of the time we don't find unusual values in the middle of the data, right? Most of the time we find unusual values on the ends, on the high or the low end. But this one has an unusual value in the middle. We're not in charge of what the data looks like. Okay, it looks like what it is. This is what it is. So therefore, this is an unusual thing. And you think about it, there's plenty of people who don't eat eggs at all. There are other people who really like them. To have somebody who only ate 1 egg is just kind of unusual. It's either you really eat them all the time or you just don't. I guess that's what this is telling us. Right? Now, what we have to understand in this situation then is how to find unusual values. How do I know that it's unusual? I just look at my probability. I'm not going to use the empirical rule. Not the empirical rule. Okay. When we're doing these kinds of problems with discrete probabilities, I'm not going to use the empirical rule because I already know the probabilities. And it's not bell-shaped. Hopefully you understand that's clearly not bell-shaped. So I don't use the empirical rule for this. I'm just going to look at the probabilities. If they're less than 5%, unusual. That's it. I'm done. Okay. Any question about this so far? All right. Now it is true, however, that we do need to find the standard deviation for some situations. So we're going to go through this and we're going to find the standard deviation. And it's not quite so simple, all right? Formula for the standard deviation looks like this.
What letter is it?
This right here, this is a sigma, and it stands for standard deviation. It's a small letter sigma. That's the standard deviation. This is a capital letter sigma, and it means add these things together. This is the letter mu, and that is the mean.
Is there a question mark or is that X? No.
That's a 2.
Well.
Good question. Yeah, it's a 2. All right, so we asked the question, what's going on here? What's the process of this thing right here? We're going to square the data values, multiply them by the probabilities, find the total, that goes in there, and then subtract the square of the mean and take the square root of the whole thing.
And the totals of what?
Of these. I'm going to take each of these x's, square them, and multiply them by the probability. So I have another column, that's what this is for, x squared multiplied by its probability. People get confused in the process here. You got to be really careful. You don't use the third column to hit the fourth. You take the first column and square it, and then multiply it by the second column. So I'm going to write down for you what this looks like. 0 squared times the probability of 0 plus 1 squared times the probability of 1 plus 2 squared times the probability of 2, et cetera, et cetera.
So you're not multiplying it by,
Okay, so
the first two columns are multiplied?
I'm using the first two columns. I square the first one and then times the second. Whoa.
So you're using the first two columns to get the fourth column,
I
right?
am.
then don't you have to square root all of those?
I am not square rooting anything right now. Right now, all I'm doing is squaring the first column, multiplying it by the second column, and writing those numbers in the fourth column.
And the next step, he says, add them all up.
The next step will be to add them all up, yes. But I'd really like to make sure that what I have is correct. Does it look correct to you?
Well, I just assumed.
Yeah, well, you're not safe, unfortunately. You might think I'm perfect. You know, so many people do, but no.
Couldn't you save yourself a bunch of steps and do it all at once? So like, find the total of all the data values and square those.
No. You have to do each one separately. Sorry. Okay, I'm pretty well convinced that that's correct. So is it 544? Okay. So this number, after I did all my addition, is 5.44 minus the square of that number, 1.6 squared. And then I do what's inside here, then I take the square root.
Should I have you go back?
Yes,
When you were writing down the fourth column,
yes.
0 and the 1, those are easy because they come up to 0 and 1,
Right.
you square them. But did you write 2 to the, squared times p and then 2 in the parentheses?
I did 2 squared times 0.12. I do, this x is not a multiplier here. This is
No, I
a
know that.
label, right? So this x is not a multiplier, this is a label.
No, I know that.
Okay,
But
So
didn't
this
you write a 2 for that x? Is what I'm saying, that
I
last x?
did over here, I
Yeah.
said, this is 2 squared times the probability of 2.
Right.
So this is 2 squared, which is 4. Probability of 2 is 0.12.
I'm
That's
just
this thing.
confusing the extra,
The data.
He meant the data value.
the data value too.
When I say P, the next number is a label. It's not a 2. It's a label telling you which probability. Oh, come on, I can do this, can't I? 5.48. No, subtract 2, that's 3.48. So that would be. Eight. Is it 1.85 or? 1.7?
Yeah, 1.697 is the.
Oh. No, that should be 1.96, which is about, no, it's 256. Oh, I was thinking 14. All right, 1.7, huh? Okay, so that's the standard deviation. Now,
Can we do each part so I can hear this? That's like wrong.
okay, so the first thing we do is that we take the first column number, we square it and multiply it by the second column number, and that number goes in the fourth column.
Okay, I just need that part in the.
Okay, this right here.
Yep.
Okay. So if you put this into your calculator, you're going to do this part inside first, and then take the square root. So if you do 5.44 minus 1.6 squared equals, you're going to get a number.
But if I don't have my 1.6 squared and then get that total, then minus that from 5.44.
And then take the square root.
the square root.
So if you don't have a calculator, you can't find the square root.
Yeah.
All right,
And that is what, that is.
that's the standard deviation. Okay, now, I try to be clear on this. People don't believe me, but it's the truth. You don't use this. We're not going to use this standard deviation for anything because the empirical rule does not apply. It's not bell-shaped. We just look at the probabilities to find any unusual values. We do not use this. But it is something that you might need to have on certain situations, and so it's available. But this is the way to get it. That's all we need to worry about currently. Okay. Now, this particular process that we're using right here, well, I'm just going to mention this to you. We might get to it later. But this process that we're doing right here is how people come up with, well, no, I guess I do have, because it's on your homework, so I'll do it right now. Okay. That was talking about how many eggs. But now we're going to talk about car insurance. Okay. We're going to have two possible things that can happen. Either you're going to have a wreck or you're not. Okay? If you are in a wreck, let's get an idea of how much that's going to cost.
Too much.
$2,000. If you're not in a wreck, it's zero. Okay? Now the next question is, what's the probability of you getting into a wreck? In a year's time. Let's say 1%. Okay. So what's the probability that you don't get into a wreck? 99. 99, right? Okay. So then, if we ask the question, if the insurance company is going to pay for this, how much will they expect to pay on average per person? How much money does the insurance company expect to pay out on average? Well, we're going to do just what we did. We're going to take this number, which is X, and we're going to multiply it by its probability. So what is that? $20. And this would be 0, right? This X multiplied by the probability. Add that up, that's $20. So the insurance company would be expecting to pay out $20 per person. How much do you think they should charge for insurance? $20, right? If they charge $20, then they'll break even exactly, right? Well, there's a problem because they have to pay all those people to sit in the office and take your phone calls. And they have to have people dealing with a bunch of other stuff. They have all the claims representatives. So they're probably not just going to charge you $20, right? Now, what things would affect that probability? People get into more accidents. What would cause people to get into more accidents? Bad drivers, bad weather, teenagers, where you live, how much you travel, time of day, drinking, other kinds of influence, right? Texting. Does the insurance company keep track of how fast people put on their brakes? They can, yes. They give you a device, you put it in your car, and they use GPS to find out how fast you put on your brakes. And they'll change your insurance rates depending on how you drive. If you're a good driver, they'll give you a good rate. If you're a bad driver, they won't.
Check what time of day you drive, because you're more likely to get in an accident.
Right. But if you come up to a stoplight and you slam on your brakes to get to the stoplight, you're more likely to get in an accident. So they keep track of that. What about good grades? Can you get a break on your insurance if you have good grades? Yes, you can. Why do they do that? Why would they give you a break for good grades?
What insurance company is that?
State Farm. Why do they do that? So what does it do for them? It lowers their risk. So then they're able to not have to spend out so much money because they're attracting people who don't have as many accidents. And the others have to go somewhere else. So then this is how, by the way, Facebook and Google and everything else also works. What are the chances that you're going to click on that cat video? What are the chances that you're going to click on this picture of name your politician? Or what are the chances that this headline is going to make you click on a thing? If you have that headline and you click on it, guess what? You're going to see more of those headlines because they're going to attract your attention and they're going to sell you stuff. That's what they're doing. They're managing this percent right here, and then they're thinking about, well, how much can we get them to buy, or how much trouble are they going to get into, all those things. They keep track of all that all the time, so then they're able to make money. That's how Facebook exists. That's why Google exists, because they sell advertisements based on what you click on. That's how all this works. Okay? If you get your master's degree in statistics, you can make over $100,000 right out of the gate. Because people are going to know that you understand this kind of stuff, and you can help them figure out their things. So if you are interested in your master's degree in statistics, then you'll really make a lot of money. All right. So for those of you that are having trouble with your homework, we're going to go over to the other room and work on it. But this is the topic for next time, discrete probability distribution. Then you can leave. Not having trouble with your homework. You want to go through it? All day.
Yeah.